The Hubble images of 3I Atlas taken on January 22, 2026 reveal one of the most extraordinary geometries ever observed for an interstellar object.
And very gladly, the Hubble Space Telescope was looking at it because some places on Earth were cloudy, and I know from observers that couldn't really take good data of it. But just a few hours ago, I received an analysis of the first data from the Hubble Space Telescope on January 22nd, and it looks very interesting.
As the Earth, Sun, and 3I Atlas aligned with extraordinary precision, the Hubble telescope revealed a phenomenon that sent ripples through the astronomical community: extraordinary geometries formed by the object's jet system. This rare alignment of cosmic forces positioned the Earth at an angle of just 0.012 radians from the interstellar object, a configuration akin to a full moon phase. For the first time, scientists were able to observe 3I Atlas in detail that had previously eluded them, revealing features so far removed from what was expected in typical comets. These images captured not just a distant object, but an enigma, an interstellar traveler whose secrets continue to unfold with each passing observation. The discovery of a four-jet system was a key feature in the new images, an unusual and complex structure unlike any comet ever observed within our solar system. Among these four jets, the dominant anti-tail jet, which points nearly toward both the Sun and Earth, stood out as the most prominent feature. This anti-tail defies expectations for objects passing through our solar system, where the jets of normal comets are typically driven away from the Sun by the pressure of solar radiation and solar wind. In the case of 3I Atlas, this jet did not simply point away from the Sun as is customary in typical comets, but instead traveled directly toward it, maintaining its coherence against the very forces that should have dispersed it. The three additional mini-jets observed around the nucleus were also highly unusual. These jets formed a symmetric triad, evenly spaced by 120 degrees, each of which radiated from the object with striking precision. Their symmetry was almost too perfect, presenting scientists with a puzzle. How could such a configuration exist in the chaotic, turbulent environment of space, especially when one of the jets appeared notably faint? The mini-jet's faintness was likely not a result of an absence of material, but rather due to the object's viewing angle at the time. This spatial arrangement and the distribution of these jets suggested a complex internal structure or mechanism not seen before in interstellar visitors. When researchers processed the Hubble images using a Larson-Sekanina rotational gradient filter, a powerful tool specifically designed to eliminate the symmetrical coma surrounding a comet's nucleus, a striking revelation came into focus. This specialized filter allowed for the removal of the diffuse, circular glow that typically obscures the finer details of a comet's structure, revealing the jets in their true form. Under normal conditions, the coma, a halo of dust and gas surrounding the nucleus, can make it difficult to clearly distinguish the specific features of a comet's outflow. However, by filtering out this symmetrical glow, the team was able to isolate the actual jet emissions, shedding light on the intricate dynamics of 3I Atlas that had remained hidden from earlier observations. With the haze of the coma cleared, the full extent of the object's structure became more apparent, revealing features that scientists had long suspected but never fully visualized. One of the most extraordinary details uncovered in this process was the sunward elongation of the surrounding glow. This elongation stretched approximately 100,000 kilometers, nearly 10 times the diameter of Earth, an astounding distance for an object of this size. This immense stretch of material illuminated not only the physical scale of the object, but also its unusual dynamics. The glowing material surrounding the nucleus revealed an unexpected shape, one that diverged from the more familiar cometary structures that typically exhibit a more uniform or irregular tail. The enormous size and the directionality of this glow pointed to an object undergoing complex processes far more intricate than what was seen in typical solar system comets. These images provided an unprecedented view into the nature of 3I Atlas, offering insights that could reshape our understanding of how interstellar objects behave when influenced by the Sun's radiation. What was once a vague, mysterious glow now stood out as an intricate and dynamic feature, providing a deeper understanding of the object's composition and behavior as it traveled through our solar system.
In typical cometary systems, the behavior of jets is largely dictated by the interaction between the sun's radiation and the solar wind. As a comet approaches the sun, the intense heat and radiation pressure cause the volatile materials in the comet's nucleus, primarily water, gases, and dust, to vaporize and be pushed away, forming the familiar tails and jets. These jets are typically oriented in such a way that they extend outward from the nucleus, driven by the forces of solar radiation pressure and the solar wind, which pushes the materials away from the sun. As the comet moves further from the sun, this process continues, with the tail becoming more diffuse and elongated, with the jet structures fanning out in a characteristic manner.
However, 3I Atlas completely contradicts this standard pattern. The most striking feature revealed in the January 22, 2026 Hubble images is its sunward-directed jet. Unlike the expected outward-facing jets of most comets, which are driven away from the sun, 3I Atlas exhibits a tightly focused jet that points directly toward the sun. This behavior suggests that some entirely different mechanism is at play within the nucleus of 3I Atlas, one that cannot be explained by the standard processes seen in typical cometary systems. The sunward-directed jet, in particular, is a crucial anomaly. Its presence implies that the forces governing the behavior of 3I Atlas are fundamentally different from those that dictate the behavior of ordinary comets, raising the possibility of new, unknown physical processes at work. This jet remains tightly collimated, meaning it maintains its narrow, focused shape over vast distances, in stark contrast to what we would expect based on our understanding of how solar radiation and solar wind normally disperse cometary material. Even in the direct path of solar forces, where one would anticipate a broadening or dispersal of the jet, 3I Atlas's jet does not spread out as expected. This remarkable persistence further deepens the mystery surrounding the object and challenges conventional wisdom about the mechanics of cometary jets. Adding to the complexity of 3I Atlas's jet system is the wobbling motion observed in the object's jets. As the object rotates, the jets are not stationary but exhibit a periodic oscillation with a 7.2-hour cycle. This wobble causes the jets to shift or precess, causing the anti-tail jet to move by approximately plus or minus 20 degrees over time. This means that depending on the timing of observations, the anti-tail's alignment with Earth can vary, making it difficult to consistently observe the jet in the same configuration. As a result, the alignment seen on January 22, 2026 was an exceptional and rare opportunity for astronomers to witness the object in such a precise alignment. During this alignment, the anti-tail appeared to be positioned in a way that allowed for the clearest observation of its structure. In most other circumstances, the precession of the jets would mean that the anti-tail was not aligned in such a way that it could be captured with such clarity. The wobbling behavior of the jets explains why previous observations of 3I Atlas did not reveal the anti-tail in a similarly prominent position. This temporary alignment gave scientists an unprecedented chance to study the object in great detail, shedding light on aspects of the jet system that would have remained hidden otherwise.
This unusual jet motion, combined with the sunward directionality of the primary jet, points to the possibility of complex internal forces within 3I Atlas, forces that are still not fully understood. The wobble, which occurs at a consistent periodicity, could be a result of the object's rotational dynamics, suggesting that the object's internal mass distribution may not be uniform. If there are clumps of material within the object's nucleus that are contributing to this wobbling motion, it could explain the changing orientation of the jets over time. This periodicity might also suggest that the object is undergoing rotational precession, a phenomenon where the axis of rotation slowly changes direction due to gravitational interactions or uneven internal mass distribution. Thus, the brief but significant alignment offered astronomers a window into the heart of 3I Atlas, illuminating aspects of its jet system that might otherwise have gone unnoticed. While the wobble and the sunward-directed jet still pose many questions, the alignment on January 22, 2026 allowed scientists to collect data that will be crucial for piecing together the larger puzzle of this interstellar object's behavior and physical characteristics. Despite months of observations and careful analysis, many fundamental questions still remain unanswered. What exactly is it that allows this sunward-directed anti-tail jet to persist against forces that should cause it to disperse? How does it manage to maintain its coherence across such great distances from the Sun? Similarly, the symmetric triad of mini-jets presents another mystery. Why does this configuration exist, and how does the object's internal structure create such an even distribution of jets? The faintness of one of the mini-jets raises further questions. Is it truly absent, or is it merely hidden by the object's current orientation relative to Earth? What physical properties allow the jets to withstand solar wind and radiation pressure?
Proposed explanations for these mysteries range from the possibility that 3I Atlas is composed of fragmented ice, or that it contains unusually large dust grains. Some scientists have even suggested that massive clumps or objects may be causing the jets to behave in such an anomalous fashion. Others are considering more exotic possibilities that may yet defy current scientific understanding. What is certain, however, is that 3I Atlas does not behave like any comet we have ever observed before. Its geometry, its jet structure, its rotational alignment, and its ability to persist with this unusual configuration both before and after its perihelion pass are unlike anything seen in the solar system. This distinction places it among the most anomalous interstellar objects ever recorded, with behavior that challenges our pre-existing models of how such objects should behave. This makes it one of the most important objects in interstellar study, a celestial visitor that pushes the boundaries of what we know about objects from outside our solar system. Despite the multitude of open questions, the significance of these findings cannot be overstated. The continued study of 3I Atlas is a rare opportunity to expand our understanding of the cosmos and to challenge long-held assumptions about the behavior of interstellar objects. While no definitive conclusions can yet be drawn, the ongoing observations and data collection on 3I Atlas are invaluable. This is a rare chance to study an object that stands as a testament to the mysteries that lie beyond our solar system, and it serves as a reminder that science is not about reaching conclusions too quickly, but about following the anomalies where they lead. As we continue to observe this interstellar traveler, the best may still be yet to come. With each new piece of data, we are pushed further into the unknown, where every discovery opens the door to even more questions. Whether or not we find answers, 3I Atlas reminds us that the universe is far more complex than we can imagine, and that some of its greatest secrets are just beginning to reveal themselves.